Hello and welcome back to Calculus 1. This is the exam 1 review. So in your infinite wisdom, you voted to have the exam next week. That means your quizzes are starting tomorrow. You should go do that chapter 2 post test. And also you should be reviewing those extremely important concepts from pre-calculus, which are reviewed in your chapter 1, but I'll give more details as we go. So exam is 10 questions, and we are talking for 100 points, right? Then you have the online quizzes as well to practice. You are looking for exam 1, quiz 1, starting 6 a.m. tomorrow, Sunday. And you can also practice taking the sample test in, what is it called? Chapter 2 post test. That's also a good thing to do. Now, moving forward, what's on the test? Well, obviously problems and hopefully your answers, right? That's on the test. And your name, that should be good too. It's helpful, right? So now, we are focusing on the first area of calculus, which is limits. But we are also going to have some of the pre-calculus things that are necessary for your survival in class. So before we hit limits, we have some of the pre-calc, right, with K's, Precal concepts that you need to know. Number 1, definition of the function. Being able to understand domain range, right, those basic ideas. Number 2, graph the function. Remember, there is no graphing calculator on the exam. Therefore, if you run into 1 over x minus 5, you need to know that that minus 5 is shift to the right, right? 5 units. So, graph basic functions. Number 3, function composition. You need to be able to add, subtract, multiply functions, but also must be able to do function composition. That's f of g of x stuff. And the last thing from pre-calculus is inverse functions. Now, these concepts are all in the first chapter of the pre-calculus textbook, which is available free of charge in the library or a tutoring center. It's called Pre-Calculus by Blitzer, and it has a chili pepper on a cover. It doesn't matter which version you look into. They have editions 3, 4, 5, whatever, and they are red and orange and green and purple. Whatever version you see, as long as it has a chili pepper on like that, right? That's your pre-calculus textbook by Blitzer. And if you are doing the pre-calculus textbook, you are going to find this definition in 1.1 and 1.2, graph functions in 1.6, 1.7, and 1.8. So I'm going to box this way and say pre-calc. So these are the sections and chapters. These skills are all reviewed in chapter 1 of your book, but it's only 5 sections and they really condense this stuff. If you need more explanations, I also have streams on these things when I taught Precal1s. You can find on my channel as well full lectures if you need to. But these are the topics from pre-calculus that will be on a test in a preparation for the rest of your calculus. You really cannot get through calculus if you don't know these guys. So that's that. And then we have our chapter 2 on limits. So in that one, we are talking about find limit by graph or chart. That's 2.2. 6. Find limit by algebra or plug-in when you can. 2.3. 7. Infinite limits plus vertical asymptote. 2.4. 8. Limits at infinity plus horizontal asymptote. 2.5. 9. Continuity. You have at least 4 or 5 definitions and theorems in there, right? We have limit at the point, does not continuity at the point, not continuous at the point, global continuity, piecewise continuity, right? All of those things. And then we have those big theorems. These are the functions that are globally continuous, and then combinations of continuous functions are continuous. So quick note there, 6 different, right? 6 different theorems and definitions in continuity alone. Number 10, definition of a limit. I'll put epsilon delta in parentheses, plus 2 graphs, which is what we just did, and that's 2.7. 2.1 is not featured on the test because that is the part of 3.1. It will be featured on your next exam, obviously, exam 2. And also calculations from 2.7 are not featured on the exam, but you have to know the theorem and the definition, which I presented earlier in the class. Problems will ask you to explain, let's say, a situation when limit does not exist. It will ask you if the function is continuous at the number so and so. You run those 3 rules. It will ask you to find the inverse of a function, if there is an inverse. It will ask you to graph, let's say, e to the x plus 3. It will ask you to prove vertical asymptote exists at, let's say, x is 7. You have to do the limit. It will ask you if there are any, let's say, horizontal asymptotes, which is going to be the limit from 2.5. We'll ask you to do the problem where you have to cancel and then do the limit. Problem where you just get to plug in, be done in 7 seconds and walk away. A problem where you look at the graph and say the limit. Problem where you do the chart and calculate 6 numbers on your scientific calculator or a solar calculator, and then be done with that. So it's a very straightforward if you know the concepts, and you can find a lot of help and a lot of hints along the way. You have that recitation review session. You also have my office hours to stop by. You can always do email instructor from the study plan of my MATLAB. you have quizzes, and you have that diagnostic test, which is like a sample exam called Chapter 2 post-test in my MATLAB. Create those temporary accounts today, so you're not going crazy tomorrow if you need to. I know vast majority of you purchased the software. I believe only 3 of you did not. So create the temporary accounts if you haven't by now, so that you're all ready and set for tomorrow at 6. If you happen to be bored today, by all means, take diagnostic tests today and know where you need to strengthen your abilities to do well. Yes?
Are we going to have these limit laws, these properties of limits? Are we going to have problems on the exam dealing with constant multiples, that aspect of it?
Well, the limit laws are simply you're adding and subtracting values. I believe I did the problem with limit laws where I said you replace it as a block. I just have to see where there are the properties of limits. And here is the example which I did in class, where I defined that the limit of f is 8 and the limit of g is -5. And I asked, what is the limit of this blah thing, right? In which case you replace each one with what they are, and then you come up with the answer. Now, if you have the constant multiple will just simply multiply the number you have over there. So if you are looking for the limit of 3f, you will just be 24, right? Because the constant multiple can be kicked outside. Limit f is 8.
Yeah, I guess it's just the notation. I don't know how important that is. Like
notation is extremely important.
Like kind of how it goes. Like you know how that c of f moves and it goes over here.
Yeah.
I don't really understand. I guess that.
Well, this says that this constantly escapes the limit.
So it's no longer an issue. It just goes like.
Exactly.
Okay. Oh, so that's what it means. Okay. And then the same, obviously, and then the same thing with these powers of groups ones. Like the parentheses going around like the function. I understand, but I don't understand the parentheses going around like the whole limit.
When we do the limit first, apply the power.
Oh, that's what that means. Okay.
All right. So the question is. So this is the cool thing. So let's say you have that the limit of x squared as x goes to 3. You know that you are allowed to plug in and get the answer if everything works out. So this would simply be 3 squared and you get the 9. But you can also use the limit laws, and you can say this is limit of x squared as x goes to 3. So then you get limit of x goes to 3 is just 3. And then you have a square and it's still 9.
Okay.
Technically what it says. Do we have any other questions, concerns regarding the absolutely no restroom and, you know, walking around and things, no cell phone use and stuff? The class, bring your, you know, liquids and sugars and things, and as Nike would say, just do it. As I would say, shut up. Yeah. Question is, can we have definition of a function? Function is a rule which assigns to each x in the domain a unique y in the range. Notation: y equals f of x. The words that we have to underline are rule, domain, range, and the word unique is underlined twice. If you kick word unique out and you leave the rest, you get a definition of a broader concept called mathematical relation, but it's not a function. You must have these words in your definition, especially word unique. So this is definition of a function. Notation y equals f of x. Now you can go and understand these rules. Word rule means formula of some sort. Domain, set of all input values. I should have said set of all possible input values. Because if you have a square root of x, -7 is not possible if you are looking for real answers. So, set of all possible input values, range, set of all output values. We cannot use word possible here because it is consequence, right, of an input. So there is no need for word possible. And finally, the word unique is what makes everything works. That means 1x goes into 1y. Imagine if you wanted to text your friend, but there was no unique assignment between the key you press and the letter is printed on the screen. So you want to type OK, you push O, M shows up, you push delete, it prints number 2, you push delete, it prints T, you push delete, oh, it deletes it, okay, great. Then you push delete again because you still have the other letters that are messed up, right? You see that? So uniqueness is what makes sure that every time when you perform an action with a function, you get exactly the same output. Meaning, I say 2 plus 2 is 4, you say 2 plus 2 is 4, right? And we're all on the same page with that. That is mathematical function. If I go to that switch, whose function is to control lights in this room, and I push it, I don't have to worry about causing a major earthquake or whatever. That light switch is going to toggle lights in this room. Not lights in the hallway, not lights, headlights on my car. It is toggling the lights in this room. Unique assignments. Doesn't matter who pushes the switch and with what, right? You go there and you push it with the elbow, lights come up, right? Then you use your nose, lights are off, right? Uniquely for this classroom. So that's the word unique. And if you take that word out, you kill definition of a function immediately because uniqueness is not there, and there anything goes, right? Now, we do have in nature things that are not functions. Circle, for instance, but we do have a possibility that 2 runners can finish the race at the same time. And even if you do the photo finish, every single pixel lines up. All right, so, all right, fine, right, that's possible. Another example of no uniqueness is one device here giving the same picture in two different places. See that? That's not a function either, because one input x, me writing over screen, produces the output on this device and on that device and online, three different outputs off of the same input, and they're all different. The internet is different than the projector is different than my tablet. So we are not saying if it's not function, it's not possible in the world. We are saying it is not, if it's not a function, we don't get to deal with that easily in calculus. So you learn the function definition, and then when you know that something is a function, you can take the limit, you can take the derivative, you can take the integral, because we say limit of f of x, derivative of f of x, and integral of f of x. That f of x better be a function so that we can use calculus. Bueno, that's the reason why we are making such a big deal out of something that you are supposed to know from pre-calculus. And it's been a year, so, right, that review is necessary. Any other questions, concerns regarding the exam? Well, that's a wrap.